Good morning and welcome to another edition of A for A levels with I am my tutor. Today we're going to go through mechanics, paper 41, May June 2020. Let's go. Three coplanar forces of magnitude 100 Newton, 50 Newton, and 50 Newton act at a point A as shown in the diagram. The value of cos alpha is 4/5. Find the magnitude of the resultant of the three forces and state its direction. Okay. So what we are going to do is we're going to resolve don't have to resolve it horizontally. As you can see vertically, these two forces vertically, since the angle is the same, vertically they will cancel off each other. Okay. So the resultant force, the direction is horizontal. So I'm going to put the resultant force F equals to 2 times 50 cos alpha minus 100 times 4/5 So I'm taking this as going to the right. So this is the direction horizontal to the left. Okay. That's it. Very good. This is a 3-mark question. Car of mass 1,800 kilogram is towing a trailer of mass 400 kilogram along a straight horizontal road. The car and the trailer are connected to a light rigid tow bar. The car is accelerating at 1.5 meters per second square. There are constant resistance force of 250 Newton on the car and 100 Newton on the trailer. It is always very good to draw. This is the tow bar. This is the car. Trailer. Force on the trailer resistance is 100. Resistance on the car is 250. Let's see, the tension on the tow bar is T. Identify all the forces. Okay, the car is 1,800 and this is 400. Find the tension in the tow bar. So what I'm going to do is I'm going to wait, let me see. Acceleration is 1.5. This is 1.5 meters per second square. Okay, now I'm going to isolate this car alone. Resultant force equals to MA. So, no, this is better. There is a thrust of force pulling the car forward. Okay. So I'm gonna do this over here for the trailer to find the tension. So the resultant force T is going forward. T minus 100, which is the resistance, equals to 400 times 1.5. So you get the tension equals to 700 Newton. That's it. Okay. Now find the power of the engine of the car at the instant when the speed is 20 meters per second. So here we have to find this force first. This force here. Force. Okay. Change the color to yellow. Okay. So we are going to take the system of forces on the car. Again, it's the same thing. Resultant force equals to MA. So you have F, which is the force of the car, minus the tension minus the resistance equals to 1,800 times 1.5. So you have F. This will be 2,700 plus 250 plus the tension, which is 700. And you have the force or the thrust in the car is 3,650 Newton. Okay, the question is on power. So P equals to FV. So the power 3650 times 20. 730. Okay, got it. Particle P is projected vertically upwards with speed 5 meters per second from point A, which is 2.8 meters above the horizontal ground. So we have A, 2.8 meters. So it is projected upwards and we want to find the greatest height. Okay. So this is another Subat formula. So you have initial velocity 5. Your acceleration is minus 10 since you're taking upwards as a positive value. At the greatest height, V is 0. So you wants to find the height. So you use the formula V squared equals to U squared plus 2AS. 0 equals to 5 squared plus 2 times minus 10 times H. So you have H equals to 25 over 20 or 1.25 meters. Okay. Find the length of time for which P is at a height of more than 3.6 meters. So you still have the same thing. U equals to 5. So 3.6 meters. So this is already 2.8 and another 0.8 meter. Okay. So it is pretty flexible. You can always start here at 0. Displacement 0 at A. So your S is more than 3.6. You still have U equals to 5, A equals minus 10. So you want to find T. So you have S equals larger point 3.6. S equals to UT plus half AT squared. So UT plus half AT squared is larger than 3.6. 5t minus 5t squared. So I'm going to multiply by 5. Make it a round value. So this will be 25t squared minus 25t. 3.6 times 5 is 18. Plus 18 smaller than 0. Should be able to factorize this. 5, 6 is 30. 5 times 9. Okay, better find this. So you can always use your calculator to find the roots. Okay, so it will save you some time on your factorizing. Oops. Seems to be a problem. Let me see. Oh, okay. Now I forgot I've done this as 0.8. No wonder you cannot get a solution. Okay. So this is 0.8. 0.8. This is 0.8. 0.8 times 5 is 4. Okay, so you have 5t minus 1, 5t minus 4, so 0. See, this you always have check and balances. So the roots is 1 over 5 and 4 over 5. So at t is between 0.2 and 0.8. So the length of time is above 3.6 should be the time between 0.2 and 0.8, which is 0.6 seconds. Okay. Next, question 4. The diagram shows a ring of mass 0.1 kilogram threaded on a fixed horizontal rod. The rod is rough and the coefficient of friction between the ring and rod is 0.8. So mu is 0.8. Force of T Newton acts on the ring in the direction 30 degrees to the rod, downwards in the vertical plane containing the rod. Initially, the ring is at rest. Find the greatest value of T for which the ring remains at rest. So here it will be when it is at limiting friction. You understand? Limiting friction, the friction equals to mu r. That is the greatest value. Okay. R. This is the weight. The weight is 1 Newton. This is the friction. Mu r, 0.8 r. R equals to 1. Friction is 0.8. So, greatest of V, T cos 30 degrees should be equals to 0.8. T root 3 over 2. I'm going to change it all to fractions. So, T equals to 8 over 5 root 3. So 8 root 3 over 15 Newton. Okay. Find the acceleration of ring when T equals to 3. So when T equals to 3, again, equals to MA, F being the resultant force. So 3 cos 30 minus the friction, which is 0.8 equals to 0.1 A equals to so 3 cos 30 minus 0.8 . So in 3 significant figures, this is 18.3. Okay, I made a mistake. R is not 0.1. R equals 0.1 plus. So there's always a check and balance when the value don't tally. T sine 30. Okay. So it's 0.8. This will be 1 plus half T. So 1 plus T. 1 plus. Okay. Drop all these things here. All these are wrong. So you have 3 over 2t minus 4 over 5 times half 2 over 5t equals 0.8. Okay. 1.72. Got this. You've got this. So again, you have to make some adjustment here. Okay. So this is minus 0.8. 1 plus 3 sine 30 equals 0.1a. 3 sine 30 is 1.5, 2.5. 3 cos 30 minus 0.8 times 2.5. Okay. Divide by 1. Okay, so it is 5.98. Okay, good. Child of mass 35 kilogram is swinging on a rope. The child is modeled as a particle P and the rope is modeled as a light inextensible string of length 4 meters. The initial P is held at an angle of 45 degrees to the vertical. Given that there is no resistance force, find the speed of P when it has traveled halfway along the arc from its initial position to its lowest point. Halfway would be here. This is 5 degrees. So this one you have to use energy. This is one. So the height it would have fallen is cos. So here I'm going to draw the triangle. One, this is 4. So you have cos 45 equals to 4h cos 45. Likewise, H1, this is H1. Likewise for H2. So this is 4 cos 45 minus 4 cos. H2 minus H1. So it is 0.867. Height fallen. So the gain in kinetic energy equals to loss in tension energy. V equals the square root of 2GH, square root of 2 times 10 times 0.867. $4.16 meters per second. That's it. Okay. It's given instead that there is a resistance force, the work done against the resistance force. Speed travel from its initial position to its lowest point is x joules. Speed of P at its lowest point is 4 meters per second. Find x. So the gain in kinetic energy plus the work done. Work done against friction is always a gain. mg h times, now you have to use the mass, which is 35 kilogram. Speed is 4 square plus x equals to 5 times 10 times. And the h is 4 minus cos 45. Okay. Times 35. 130 joules. 130 joules. That's it. Particle moves in a straight line AB. The velocity v of the particle t seconds after leaving A is given by this formula. Where k is a constant, the displacement of the particle from A in the direction towards B is 2.85 meters when t equals to 3 and 2.4 meters when t equals to 6. Find the value of k, hence find an expression in terms of t for the displacement of the particle for A. So S displacement is integrate v dt. As we're going to find the displacement function in terms of t. K square minus 10t S equals to k e cubed over 3 minus 5t square plus 21t. C. Now, there are two set of values. S is 2.85, T is 3. S 2.4 and T is 6. So let's take the first one first. S 2.85, T equals 3. 85. T cube is 3 cube over 3 is 9. Minus 5 times 9, 3 square, which is 45. Plus 21 times 3 is 63. C. Okay. So 2.85 equals to 72 minus 45 is 27K plus C. Okay. This will be my first equation. Second is when S is 2.4, T equals 6. So 2.4 equals K. 6 cubed is 216 over 3 is 72 minus 5 times 6 square. 6 square is 36. 80 plus 21 times 6 is 126. Let's see. So you have 4 equals 198 minus 180 is 18K plus C. This is equation 2. Equation 1. Equation 2. 45 equals to K equals to 0.05. So we have found K. Substituting to find. So it's sub into equation 2. 2.4 equals to 18 times 0.05 plus C. 0.9, 1.5. Okay. So now you can write down the equation. S equals to 0.05 1 over 3t cubed minus 5t squared plus 21t plus 1.5. Okay. Find the displacement of the particle from A when its velocity is a minimum. So, minimum when dv over dt equals 0. So you need to differentiate 3t squared minus 10. 2t minus 10. 2t minus 10 equals 0. T equals to 5. So this is the time when velocity is minimum. S equals, using this equation, 0.05 1 over 3 times 5 cubed minus 5t squared 5 squared plus 21 times 5. Okay. Last question. A particle P of mass 0.3 kilogram lying on a smooth plane inclined at 30 degrees horizontal is released from rest. P slides down the plane for a distance of 2.5 meters and then reaches a horizontal plane. There is no change in speed when P reaches the horizontal plane. Particle Q of mass 0.2 kilogram lies at rest on the horizontal plane 1.5 meter from the end of the inclined plane. P collides directly with Q. It is given that the horizontal plane is smooth and that after the collision, P continues moving in the same direction with speed 2 meters per second. Find the speed of Q after the collision. Okay. So using energy, you can find the speed of P when it reaches the bottom of the inclined plane. Here, all the diagram is drawn for you, so it is quite easy. So H equals to 2.5 sine 30, which is equals 1.25 meters. So using gain in kinetic energy equals to loss in potential energy. In the same thing, 2GH 2 times 10 times 1.25. So this will be 5. Before colliding with Q, the speed is 2.5. So Q is at rest. P Q 0, this is 5 meters per second. And it is given P continues moving with 2. So Q was the speed. So P is 0.3 kilogram, Q is 0.2. This is 0.3. Law of conservation of moment, 0.3 times 5 plus 0, which is the momentum of Q, equals to 0.3 times 2 plus 0.2 times V. Equals 4.5. Okay. It's given instead that the horizontal plane is rough and that when P and Q collides, they coalesce. Coalesce means they join together and move with speed 1.2 meters per second. Find the coefficient of friction between P and the horizontal plane. So here, if you want to find the coefficient of friction, you need to find the friction. Okay, to find the friction, you need to find the acceleration. So let's see what is the speed of P when it collides with Q. So again, PQ V0, 0.3, 0.2. After the collision, they stick together, move at 1.2. Total mass is 0.5. 0.3V plus 0 equals to 0.5 times 1.2. So they move V by solving, you get 2 meters per second. So final velocity when it collides with Q is 2. Initial velocity when it reaches the bottom of the hill is 5 meters per second. Displacement is 1.5. And you want to find what is the acceleration. So you use V square equals U square plus 2AS. So V square is 2 square equals to 5 square plus 2 times 1.5, which is S times A. 21/3. So A is -7 second square. Okay. So now you have the acceleration. So the frictional force MA, which is P 0.3 times -7, which is 2.1 Newton. Now the frictional force is mu R. Mu times R. R would be the same as the weight. Okay. 2.1 equals to mu. The weight would be 3. Mu equals to 0.7. That's it. Thank you very much for following. If you like the video, like and subscribe. if you want the work that I've done today, put a comment and I will email it to you. For now,